Welcome back, and in the last video we saw the law of cosines, and so now it's time to get some practice with it. So one type of example you're going to encounter is just working with triangles, and which makes sense because the law of cosines deals with triangles, but it is more so just being able to solve it. And remember when we say solve, it's find all missing sides and angles. Okay, so what I'm going to do is just draw a generic triangle, and the thing I want to figure out is this going to be, obtuse, acute, or right? Well, it's probably not going to be right. But what we can see here is that when we look at the three side lengths given, one is much larger than the other. So I'm going to draw a triangle that I believe is going to be obtuse. Okay, so something like this. It does look slightly right, so maybe let's exaggerate this a little bit more. Okay, and then I'm going to call this, okay, so before I give it names, I want to make sure that the side lengths are correct. So this looks to be like the longest side, so 62, which would make this angle A. And then the second is 48. Oops, let's make that 48. And so this would be angle B. And then C, the shortest side length, would be directly across from angle C. Okay, so I need to figure out the angles. Okay, and so here it doesn't matter which one you start with. Let's say I want to solve for A first, and to do that I'm going to use law of cosines. So to find A, I'm going to say, okay, the formula for law of cosines here would be A squared plus B, or is equal to B squared plus C squared minus 2B times C times cosine of the angle included. Okay, and so now it's a matter of algebraic manipulation. I'm going to just kind of show you the math and then jump to the answer. So move the 48 over, 48 squared over, move the 41 squared over. Okay, minus 2, so then that's still equal to minus 2 times 48 times 41 cosine of A. Again, I want to isolate cosine A because I need to do an arc cosine eventually. So I will need to take all of this. So again, I could punch this in a calculator. I'm just going to show you symbolically what you would end up doing. But whatever this number ends up being, you'd have to divide it by the quantity. Make sure to do parentheses, 2 times 48 times 41, and then that's all equal to cosine of A. Okay, and so let's punch this into our calculator now. And so here, if I punch this in my calculator, I got 0.0358-ish is equal to cosine of A. And then I can do the inverse cosine of both sides. 0.0358, and then this would just equal angle A. And then with this, I can do the inverse cosine of my answer, and I get, angle A is approximately 87.9 degrees. So my original drawing wasn't exactly correct, but that's okay. Okay, so I have angle A. I need to know one more angle before I can, use that property where all angles sum to 180. Okay, so let's use angle A in conjunction with the given information to find angle B. Okay, and so there you can use law of sine or law of cosines again. I'm going to use law of sines just because it's going to be quicker for me. So I'm going to do sine of, it's 87.9 degrees all over 62, so angle to side, is equal to sine of B over 48. Okay, and manipulation, okay, I'm going to say there's a few steps that you have to do in here algebraically, but what you're going to end up with is that B is going to be equal to the inverse sine of 48 sine 87.9 degrees all over 62. Okay, and we can put that in our calculator. And when we put it in our calculator, we get approximately, I'll say, 50.6 7 degrees, okay? And then consequently, you can say, okay, C is going to be 180 degrees minus 50.7 degrees minus 87.9 degrees, and here you get that C is, again, approximately, since everything else is approximate, 41.4 degrees, okay? So with all this, you have your three unknown angles, and as you were given your three sides to begin with, you're done. Okay. So we dealt with kind of a generic example where we're given some side lengths and work with it. Now we have to do a word problem. Why? Just because. Okay. So again, pause the video, read the context if you wish, and resume when you're ready. In the context, it says that, we can, or the triathlete can go from A to C or B to C, right, along one of these paths. And it says that from A to B is 360 meters. A to C is 850 meters. And B to C is 770. Okay, so, we're getting another scenario where we're given all the sides, right? And so we can use law of cosines, but what are we actually, being asked? That would be important to know. We want to know what the angle they must swim at to reach C from each of A and B. Now, technically, that angle, it isn't defined whether it's this one or this one. Similarly, for angle A, it isn't defined if it's this one or this one. So we should typically we report the angle that's counterclockwise, like the positive angle. So we're going to go with those ones that are the double things. So we might just have to take 180 minus our answer to get each of these. Okay, but let's focus on finding angle B first, just for fun. Okay, so for angle B, you're going to start with, if this is angle B, right, you're going to do law of cosines for that. So 850 squared is equal to 770 squared plus 360 squared minus 2 times 770 times 360, and then cosine of angle B. Okay, so again, what you're going to do is you're going to take the 850 squared, subtract the 770 squared and the 360 squared from that, divide all that by the quantity negative 2 times 770 times 360, and then you're going to do inverse cosine of that whole thing. Okay, so again, you can do multiple steps for that. I'm just doing it in one, and we can punch that in our calculator. And when you do that, you end up with that B is 90 degrees. So this diagram is a little deceiving and clearly not to scale because B is actually a right angle. Well, that's fun. Okay, but we're not going to, let that influence our decisions because in this case, you can just use normal trig functions. Okay, so in the spirit of using law of sines and cosines, so we know that angle B here would be 90 degrees, and then for angle A, we can do law of sines to get this angle in here. Okay, so I'm going to call this angle A, right? So law of sines, I do sine of A over 770 is equal to sine of 90, which is 1, over 850. Okay, solving for A, I would do, 770 sine 90 over 850, and then do inverse sine of that whole thing. So then for angle A, I get 64.9 degrees about, okay, after you round, okay. And then the question is, at what angle must they swim? So if we assume that, they would enter this, then the angle that they would actually swim at would be not 65 degrees, right? We would measure counterclockwise so that it's positive, and the actual angle. So here you would say they would swim at 180 minus 64.9, okay? Or if we, calculate that out, it would be 115.1 degrees, okay? And so that would be our answer for A. For B, here they would swim directly at 90, right? Again, that would be measuring counterclockwise. So here we would just say they would swim at 90 degrees. Okay, so there we go. We've answered the question, and even though it was a right triangle, we were able to still use law of cosines and law of sines.